All right, let's do it. It's review week, so it's time to look at what's winning in the polls. Well, I guess today's the one that was predetermined. OOP and Python. My plan for this is to open up homework 2. I suppose I already have it open up, and see how far we can get in homework 2 in Python. Seems like an okay plan. It's a program you're familiar with. You're familiar with a lot of the classes should work. And I can focus on the syntax of how to do those things in Python. So that's the plan for today. I forgot to ask what Paul did for his Python examples, but I'm sure he did something probably not the homework. So if you want another example, check out Paul's. Wednesday's going to be the TA lecture, and it's starting to look like Project from Scratch is just going to be 2 days. There's a lot of demand for that, so we'll probably do that. Going over LO3AO, got a lot of traction. We got 25 hints, or 25 upvotes, so genetic algorithm, that last Friday. When we go over a project from scratch, we'll include Git, all this Git stuff. Project organization will be from scratch, so creating packages and all that, organizing everything. The TAs, they can handle that one. I gave them a heads up that you want to hear about courses and not just careers, so hopefully they'll take that to heart and start talking about courses. If they don't, just interrupt them and ask them questions. Be like, hey, what about courses? What courses should I take next semester? How bad is 220, 250? Is it as bad as they say, etc.? And hopefully they'll answer your questions. And project from scratch, again, with 17 votes. More explanation about project from scratch. Actually, what I need is ideas of what to build for that project. What do you want to see? What's our goal for that project? This one is kind of nothing's a clear third place winner here. Going over genetic algorithm and project from scratch are the clear 1 and 2. This is kind of a third, but with only 11, I might just kind of talk about this for a little bit. Have an off-the-cuff, here are my opinions on a variety of languages, and leave it at that. And just have that cut into one of the 2 project from scratch lectures, because 11 upvotes compared to all the traction that the other ones got, we'll get something. This one I'll leave to the TAs as well. That's what they prepare, what they've done in the past is just careers in computer science. So I'll leave that to them on Wednesday. The singularity. GUIs, so the project from scratch will include a GUI. And then this, again, project from scratch with GUIs, getting some traction. Neural network, didn't get too much traction. When I go over genetic algorithm, if I go over everything and there's time, I'll just go into the neural network as well. Oh, this one was kind of a number 3, too, with 14 votes. How to hack websites and programs. If you can, I need a little more to go off of. I mean, I can just take that and run with it, whatever I feel like doing. But specifically what you want to see. So I've kind of hacked Piazza right here to remove all your names. I can show you how to do that, I guess. Yeah.
Can you hack the Russian government?
Yes, but you got to pay me.
Oh,
I don't do that for free.
That's fair, that's fair.
I guess you are paying me, so maybe I should.
Technically, we are. Now, I actually did have a question. What percentage is this specific class at for the?
Oh yeah, that's the next tab. I'll go over to that. I guess I'll do it right now. Piss off. I'll get back to that one. I want to go through the rest of this because there's nothing else to talk about. LO2, that's super vague. Also, you can upvote your own comments. So even the commenter didn't want this. Deploying Python servers accessible to everyone. This is something I do in 3.12. If you're interested in that kind of stuff, 3.12 is where you want to be. I wish that did get more traction because I'm all prepared for that for my 3.12 lectures. And different examples, application of polymorphism didn't get traction. And jobs got a little bit of traction, but that's what do I say? The TA's job. All right, so now I got to do this in a way that's not going to dox anyone because the eval site logs me out immediately. It's very frustrating. Let's go to course evals, log in again. Don't duo me. We're getting there. So 55 looks like this section is in the lead, 55%. If we can get that to 60, I can open up that first assignment. And hopefully we can get up to the 80. I'd like to see this hit an 80 so you can get that genetic algorithm thing. I'll update the numbers. I think these are pretty much up to date. I've been updating my comment on the Piazza post. I'll keep updating that whenever I check this. It's pretty much up to date. But you're in the lead, but we're still short of that first incentive. So let's get up to that 80% and get those incentives. If anyone doesn't know what I'm talking about here, the incentives, if we get to 60, there's some incentives. 70 is the next tier, 80 is the next tier. You can check the Piazza post for exactly what you get. All the incentives help you out with the application objectives. And there was a call in the chat last time to get some incentive in there for people who already have 10 application objectives, but I haven't heard any suggestions yet. So if you're a holdout and you're like, I already got 10 AOs, I ain't giving you no feedback, let me know what you want. This can be a negotiation. And, it's kind of a bribe, but you can counteroffer. So let me know if you're in that situation and you want something.
Free AO money.
Well, if you already have 10 AOs, what's a free AO going to do for you?
Gift an AO?
What's that?
Gift an AO?
Gift an AO? Maybe.
If we reach 90%,
Maybe.
we get something.
Would that help anyone in that situation, though? The hard-ass prick who's like, I already got my 10 AOs. I don't care about no one else. I don't know if that'll
Wait,
hit
hold on.
that.
You have a Twitch, right?
Yes.
Maybe if enough of people do it, you get a stream on Twitch for like a day.
That I'll do.
Yeah.
That'll do.
Yeah, for the learning purposes of this class.
Oh, of course. Well, it'll be outside of class time, so it'll be whatever. Yeah, that if you'll write that up as a suggestion. Follow up on the course incentive post. If somebody suggests that and gets some traction, yeah, I'll add that as an incentive. All right. So let's do what we came here to do. Make sure what we got here. Well, installed Python, made a project, made a class, added inheritance, went through the game object health potion demo. Oh, that's a good one. And wrote string methods for each class. Oh, I didn't plan on doing string. Maybe I can do that. I didn't really do toString in Scala either, to be fair. Hack the song ratings website. Oh, that's so easy to hack, though. Sql Injection, I don't.
So long.
I believe yeah, it does. My song rating site uses MongoDB, so I won't be able to do any SQL injection. And MongoDB doesn't have a similar vulnerability. Extra credit for next semester. How does that work? Do I have to tell Ethan, hey, this student, extra credit on day one? Maybe. No, that wouldn't work. Ethan would never go for that. And I don't even know who's teaching 250 next semester. I haven't looked that up. All right, so let's open up a Python project. So I have PyCharm. You can use Python in IntelliJ. I mentioned this briefly on Friday. You can use Python in IntelliJ, but I think you have to download a plugin. It's not that big of a deal if you search the plugins or just search online, how do I do Python in IntelliJ? I set it up on my other laptop, but it was so long ago I don't remember how, and I never set it up on this one, so whatever. I'm just going to use PyCharm. PyCharm, made by the same people, JetBrains, as IntelliJ. It's a very similar interface. Everything's pretty much the same. If looking at this, you might even think that this is IntelliJ. It's just all the same look and feel. Everything's set up the same way, except it's set up for Python. So you can go to JetBrains' website. You can say, Google download PyCharm. You'll get there, and you'll be able to get the either community edition without any hassle. I think there's a community edition. Or if you have your EDU license, or you get your EDU license, get the professional or whatever they call the next tier version of it to get more features. So I created a brand new project. I opened up in PyCharm. I just did new project. That's the only thing I've done so far. And then it gives me a main file. It pre-populates this with hello world. I deleted that so I can start straight from scratch. So if I start writing code, we can start doing Python in 1.16. So hello Python. We started with hello Scala. I already forgot what language we used. And I run this. What I did was right-click the file, just like we do in IntelliJ. Hit run, and I printed hello Python. We got our first Python program in an IDE. So in 115, you use the internet IDEs. You went to the website and then typed your code there. We usually don't do that. Now that you're beyond 115 and you're capable of downloading, installing, setting up an IDE, which is kind of painful. You remember the IntelliJ initial setup. For some of you, it goes nice and smooth, but if you run into an issue, it can be very painful. We don't want to go through that with everybody in 115. Hey, welcome to coding. It's going to take you hours to set up the program. It's horrible. So we use online IDEs there. Beyond 115, you're going to use either IDEs like this, or if you're brave, you can use just raw text editors and write your code that way. Code is just text. So you can do that. I'm going to use PyCharm because I like IDEs. They're there to help us. Why not let them help us? When we write a Python program, we'll usually not just write it as a script like this. We're going to say if. I'm just going to use the shortcut so I don't have to remember it. Main. To write a main method, this is the syntax for that. We're going to say if name equals main, then our code. So this is the syntax we use for a main method. And now I get my arrow in the sidebar here in the gutter, where I don't get that if I'm writing this as a pure Python script. So I want to write this as a Python program. I can run this, run the main method. The difference between these is this code. If I import this file from another Python file, this code will not be executed, which is the reason why we like main methods in Python. If we have this without a main method, and I say in another file, import main, it's going to run that code. It's usually not what we want, so we're going to throw it in a main method. Actually, I only want a main method here. Actually, I don't even want a main method. I want to go to the homework and start writing features. So let's go right from task 1. We're creating items is the very first thing. In a package, store.model.items.item. You know what? Let's do the whole package thing. So I'm going to create new directory. I don't think there's a difference between new directory and new Python package, but just to make sure. New store dot, let's see if I can create them all at once. Model.items. Piss off. New store.model.items. Oh yeah, because it does my inits, which I'm going to delete because I don't like them. And then new Python file item. I'm going to create my item class. So let's start talking about the syntax for a class in Python. It starts just as we would expect in Scala with the keyword class. So class, give it the class name, and then a colon. So in Scala, we would put the constructor right there next to the class name. Not so much in Python. We're just going to specify the class. That opens up a new block of code. And of course, instead of braces in other languages, we're using colons and indentation in Python, because Python loves white space. And then to write a constructor, this is a lot just for the first one. I'm realizing I have to talk about like every topic just for the constructor. But for the constructor, we're going to define a function inside a class, so it will be a method. And the constructor, we have to name init, underscore, underscore, init, underscore, underscore. That's a very special method name in Python, which means this is the constructor. Whenever we have a method in Python, there is a required parameter, self, which is the same as this in Scala, except Python forces us to be explicit about this extra parameter. In Scala and any other language, this is a hidden parameter. It just kind of is there for no real reason. But it is actually a hidden parameter to any method call. Every method call gets a reference to the calling object in this in most languages. Python, they use self instead of this, and it's explicit. It has to be the first parameter in any method you write. So the constructor is going to take an instance of the calling object in self, the description of the item, I'm going to say description param, I'm going to do that to avoid naming conflicts. And base price. In Python, for whatever reason, Python, the language, the convention is to not use camel case, but instead use underscores. So I'm going to follow the convention of the language I'm using and use underscores to separate my words. And then, so in Scala, when we have constructor parameters, they automatically become state variables. And I would just have description param and base price as state variables. Not so much in Python or really any other language. That's something Scala does, which kind of have a love-hate relationship with that. But in Python, you have to be explicit. Because you might want parameters, constructor parameters, that don't automatically become state variables. Maybe you want to process them first and then set them as state variables. There are other things we want to do, Scala. So in Python, you got to be explicit. Self.description, I'll name it state var to be clear, is going to equal that description. So I'm going to do self dot, which is required in Python. If I do this, description state var equals description param, well, this is how we declare variables in Python. We don't use var or val or const or let. We don't use any of those in Python. We just start using a variable, and then it is automatically declared by Python. So if I do this, Python's thinking that I'm declaring a local variable, which is not what I want to do in this. I want to create a state variable, so I have to be explicit and put self here. I have to be explicit that this is going to be a state variable. And I'm going to set it equal to the parameter variable. And same thing here. Base price, except I'm not going to get cute with the names on this one. Base price. So you can reuse names still like that. I did it with description, mostly because I want to just call that description both times. But I'm going to have a description method, and Python gets confused when you have a state variable and a method with the same name. Yeah?
What's the init, the equivalence of?
What's the init? So the init, this is how we declare a constructor in Python. So this is my constructor. My constructor, I created an item class, and the constructor takes two variables, a description param and a base price. And in Python, we don't have any types, so that's just it. It takes two things. We do have, Nicholas will be mad if I don't mention this, but we do have something called type hints in Python. So we can use the same syntax that Scala does to give what's called type hints. Types aren't enforced by Python, but if you add your type hints like this, your IDE can start enforcing some of this and give you hints, I guess. Hints about the type. So now that my IDE can tell that this takes a string and a float, and then it just makes my life easier, because if I do something stupid, the IDE is going to be like, hey, that's a string and you're treating it like an int. Maybe you don't want to do that. How difficult is it to switch between languages? It gets easier over time. It can be tough at first, but it gets easier over time. Especially with all our IDEs. There's so much stuff to help us these days. If I start typing something and thinking in Scala right now, the IDE is going to be like, this is Python. And I go, oh, yeah, Python. All right, so that's our constructor. We need a few methods here. One named description. It doesn't take any parameters, but we still have to add self. That has to be explicit. And this is going to return. We have to use return statements again. Scala doesn't force us to, but this does. And I have to be explicit self dot description state var. So this is a method that's going to return that state variable. And if I named this state variable just description, Python gets really confused and says a string is not callable. Is the error we're going to get if I do that. We need another method, price. Which for objective 1 just return the base price. Right, that's everything for the item class, right? Constructor, description, set base price. and a method set base price. Do I go with the homework doc or the convention of the language? I'm going to go with the language. Set base price. This is going to take a double. And update that state variable. Set base price, got all that. And then the next thing is going to be self-checkout. So we have a class defined. It has a constructor. The constructor sets a few state variables, and then we have some methods. So we got some stuff we can work with. Next thing I want to do is go back to the main. Actually, I'll do something a little different. But we'll go back and use this. One thing I want to mention while we're here is you can declare variables out here. But it's almost never what you want. So you can declare variables outside of the methods. These do not become state variables, and this is one of the first things when you're learning classes in Python. This is what everyone wants to do, because that's how you do it in most languages. You just put variables out there, and they become state variables. This is not a state variable. This is what's called a class variable, and this variable will be shared between all objects of this type. Every object will have the same thing. It actually doesn't belong to any objects. It belongs to the class itself, not objects of this type. Almost never what you want. Sometimes it is, on occasion it is, but usually not what you want. So we don't put variables out there unless you very specifically want a class variable. Sometimes you do, often you don't. We never even did that in Scala. We never had class variables in Scala. We kind of did in one of the examples when I had an object with state was the object name, and it was an object that had some state variables with it. And I only used that to introduce classes. That was just a segue into classes. And it was very brief, way early in the semester. We didn't really do anything with that. Usually not something we want to do. So you only make state variables in the constructor. So any state variables you want in the constructor, you need self.state variable name and then set it equal to something. You can't create any state variables after the constructor is called. You can't create any before or anywhere else than the constructor. Anytime in the constructor you have self.something equals, you're creating a state variable, and that's the only way to do it.
Does Python have multiple constructors for a class? Could you do without the base price?
I don't think so. Does anybody know? Does it have constructor overload? Oh, let's just try it. I don't think it does, because how's it going to know which one you're calling if there's no types? Yeah, it doesn't even want me to. But what you can do, like I can give this a default value and then kind of pretend that I have an overloaded constructor that way. And what you'll see in a lot of Python libraries is you're going to have an extra parameter that's called k-words, I think it's usually called. Keyword args is what it stands for. I forget what the shortened version is. But they have keyword arguments where you can say when you call a method after the positional parameters, which are the ones like position 1 is the description param, position 2 is the base price. After all those positional parameters, there will be a keyword arguments parameter where you can specify, where you can specify, like if I have some method call, and after I have my parameter, I'll say some other param equals, whatever. So you can kind of have constructor overloading by naming your parameters. Have your positional parameters, your arguments in this case, and then specify any other arguments that you want to override. And any of the keyword arguments, you only set the ones that you want in that case. So that's kind of Python's way of doing overloading. I don't believe it supports any other way of doing it. All right, so I don't want to use that main method actually. I'm gonna create my tests. Pretty sure it's not going to break when I keep deleting those inits. And it like specifies that as a package. Pretty sure PyCharm figures it out for me. And let's create some task 1 testing. I'm not going to spend too much time on the testing because we're here to talk about OOP. But I do want to show how to use the objects, how to use that class that we just created. So I'm going to write a test for it. So first, I need to import that. It's in a different module. So I'm going to import store.model.items.item. Import item from. I always think this is backwards. I get it wrong every single time. So from this module, from this item module, so this is an entire module, this Python file. So from this file named item, I want to import the item class. So I'm going to import the item class from that package. And I can have multiple classes defined in that same file. When we get to modifiers, I might dump them all in one file. I don't know. Depends how I feel when we get there. And now I can create items. What are we selling today? Apples? For $1? We don't use the keyword new in Python. Python, when they created the language, they said, you know what? We're not going to type new every time. We're just going to call the method, call the constructor. So I'm calling the constructor. So I'm calling the constructor, which is this method, which takes my description param and my base price. Let's get rid of this. And then if I want to test this, I can just say assert. Actually, let's print it first. Print apples.description. And I can call those methods. So this should print apples to the screen. Yay. And it goes nice and fast, no compilation. This is an interpreted language. So I hit that go button, and it goes. I can also change this a bit. To actually write a test case. If I rerun this, it works. And if I intentionally mess up my test case, I'm going to get assertion error because my test failed. So I have a unit test. I'm just checking the description of my apples. But this is how we're going to check things. And we can have our compare doubles. Let's get this out there just so we can do some testing. A, B, return. What's the best way to do this in Python? I guess I'll just do it this simple way. Math.abs, A minus B, less than fabs. Floating ABS. Apparently you can't take absolute value of ints in Python. Am I reading that right? Yeah, and I think I can get away with equal here, but I don't want to take the risk. So I haven't tested that. And then assert compare doubles, apples.price, and 1.0. Oh, come on. Apples.set base price to 2.0. We got some inflation. And 2. And my test should pass. So we've created an instance of our class, an object of this type item, by calling the constructor, giving it the parameters we want, setting those state variables to those values we want, and then creating a few methods that use those state variables. So that's our first class in Python. in, oh, it actually took 20 minutes. I thought we'd get farther in 20 minutes. So that's our first class. I think I'll skip self-checkout, at least for now. I don't think we'll have time to do self-checkout. And there's just a lot of methods to write, number pressed and enter pressed and all that. But because I do want to get to inheritance. Do I have a blank page on here? What the hell am I doing? Because I do want to get to the modifiers. So let's just work with the item class and build these modifiers, because this uses inheritance, and I want to show you the syntax of Python inheritance and overrides and all that good stuff. So we're going to create a class modifier, and then sales, sales tax, and bottle deposit will all implement modifier. So let's create, did I put these in a sub package? In the items package. So new Python file, Jupyter Notebook. No, I don't want a Jupyter Notebook. New Python file modifier. New Python file sale. Sales tax. Bottle deposit. All right, so let's write another class. And to be honest, I don't know if Python has an abstract. I believe it doesn't, but maybe there's just different syntax for it. I don't think it really has abstract. Yeah, Python's kind of compiled, but kind of not. It's complicated. So modifier. And we need a couple of methods here. I think we have, did I make the modifier take constructor? No. Constructor with no parameters that doesn't do anything? Why even define it? So we don't need a constructor in Python. And I'm going to do def price, which takes just an instance of itself. I'm going to pass, which is my favorite keyword in any language. Pass just means do nothing. So why not? Def, actually, this isn't price, update price. Update price and compute tax. And I don't need these to do anything. I'm just going to pass on both of them. So I'm going to have to implement these when I extend the class. But we don't have a compiler. We don't have types. We don't have a lot of the things that we have in Python, which is why Python's not suitable for this class for 116. So a lot of it's up to us to manage, because Python's going to kind of let us do what we want. So it's going to be up to us to manage. And I'll double check this one too, but I'm pretty sure we can't even have abstract classes. I don't think there's any way to actually define something as abstract. You just have a method that doesn't do anything that's kind of an abstract class, and then we'll pretend it is an abstract class. So now we want to extend that class. So I'm going to create my sale class, and here the syntax is going to look confusing because we're going to add parentheses after the name of our class, which in Scala we're trained to think constructor. If you put parentheses here and give it a type, that's how we're going to do inheritance. So I put in these parentheses modifier, and now I'm extending the modifier class for my sale class. Import, no, I'm still going to do it backwards every single time. I will never get used to that. From store.model.items.modifier, import modifier. And now I can override those methods to actually give them some implementation. Sale takes a parameter, though, double representing the percentage sale. So sale will need a constructor that's going to take the percentage off, and then store that in a state variable. And I'm typing this instead of self. That's one of the things that's tough to switch between languages. And I need to override those methods. So I'm going to go to my modifier class and do a little cut and paste because I don't feel like retyping those. There's no override. You just define the methods. Again, I'm pretty sure, I don't want to mislead it all, so pretty sure override doesn't even exist in the language. Maybe it does with a different name. So pass is different than returning null. I believe this will, and since I don't return anything, it will return, I think, none, an object of type none, capital N. And I could explicitly return null or whatever I want, or none. I'm just going to do pass. But you need something here, because Python needs something in the indentation to know that that block of code is over. So pass literally does nothing, but it's there just as a placeholder to say, yes, I know there's a block of code here. This block of code intentionally does nothing. But we actually want to do something here. So update price takes a price. Oh, it's supposed to take a price here. Price. 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 I wonder what that says actually. Signature from the base method in class modifier does not match. Cool. I like that. Price. So I can't overload the methods is what it's saying. And then update price is going to be percent self dot percent off over 100. How does math work again? 100 minus the percent off over 100. So if it's 20% off, this should give me 0.8. Good. Return price times that. The order operation shouldn't matter there, I don't think. Maybe it does. I'll make sure just by adding my parentheses in so I don't have to think about, go away, Siri. That should be fine. And then tax is 0 because it's a sale, it has no tax. So we're overriding 0. Return 0. So we're overriding those methods just by defining methods of the same name. And you saw the warnings that it gave me. If I didn't match the parameters from the base class, it's saying, hey, you effectively have 2 methods with the same name with different parameter lists. Fix that. Because I am overriding those methods. My IDE is realizing that I'm overriding them. If I change the parameter lists, it's not going to like that. But if I change the method name, it's going to be fine with it again because I'm not conflicting with the base class method that I'm overriding. So we don't use the explicit, which kind of drives me nuts, like be consistent. We're not explicitly overriding, it's implicit. So when Python has any method, it's like, no, you're explicitly taking the parameter self and we're going to force you to put it there. But then when you're overriding methods, it's like, nah, it's good. Just don't worry about it. So it's a little inconsistent, but some things are more explicit, some things are less explicit, depending on, as you're switching languages. It's one of the big changes you'll see. So here's our sale. Same idea. Sales tax is not percent off, but percent tax. Tax is going to be mostly the same math. Update price doesn't do anything. It returns the original price. And then percent tax. Our math is a little bit different here. It's percent tax over 100 And that's it, right? Price times percent tax. If my tax is 10, it's going to give me 0.1 times the price. That's going to give me the tax. Okay. So just a little bit different than the other one. And then borrow deposit. Let's knock this one out too. Takes the deposit amount, price, and this is independent of the price. We just return that deposit amount. Any questions at this point? That's like 2 weeks of content in 116. So I hope there are questions. Yes.
You have to change the name of the class.
Oh, yeah, I didn't change the name of the class. Thank you. Python does love runtime errors. And then in item class, we want a few things. We need our add modifier. This is going to take a modifier and add it to a state variable. State variables have to be declared in the constructor. That's our only chance to create state variables. So I'm going to need to create that in the constructor. Modifiers, sure. I'm going to make that a list. And we don't really, we don't get one of them big benefits that we get in Scala of polymorphism. With Scala polymorphism, we can create a data structure with mixed types. Well, Python just lets us do that anyway. As long as, if we're storing a list of things and then doing something with everything in that list, as long as what we're doing, everything in that list has the method that we're calling, it just works without any inheritance or polymorphism or any of that stuff. So we don't really get to see the benefit here. We're just going to make sure everything we put in this modifier list is actually a modifier, but it's up to us to keep track of that. And if we mess it up, we get one of them Python runtime errors. We're not going to know until runtime things are going to break, and then we got to go and debug. Scala, you get a lot of compiler errors. You got compiler errors all semester because the compiler is helping you out and trying to say, hey, this doesn't look right. Let's fix this before we go to run this thing. Python's going to be like, nah, it looks good. Let's run it. Oh, wait, I crashed. Oh, fuck. And then it's going to be hard to debug those things. The compiler does help us out quite a bit. So .modifiers .append the new modifier. And we got to update our price, our base price, the price equals self.base price for modifier in modifiers. I didn't do self dot modifiers. We always have to use self here. For modifier in self dot modifiers. Why don't you like that? I'm just going to pretend that error doesn't exist. We're going to end up returning the price. And then the price equals modifier dot. I shouldn't get any. Oh, I do get type hints, actually. I do get hints in my ID. Update price of the price. You really didn't like my parentheses. I thought I would get away with that one. So I'm going to iterate through all my modifiers, tell them all to update the price. You all did this for your homework. We're all beyond homework too. But I'm copying the base price. I'm never modifying my state variable is the big thing that we wanted to do on this objective, is making sure that you're never modifying the state of the object on the heap. So we want to make a copy of that and then modify the copy, return the copy. Base price never changes unless set base price is called. And we also had tax. Tax, same idea, except the price that we use is going to be from the price method. We want the price after sales. You're not charging me tax on the original price. I'm paying tax on the sale price. Something's 50% off, paying 50% less taxes on that too. You can take your taxes and shove it. It's always based on the sale price for any sales applied. So the price, and then tax, the tax, so it's not conflicting with the name of my method. The tax is 0. My modifier, compute tax on the price, that's good. And the tax plus equals that, and then return the tax. Looks like all the features we'll get today. Are there any questions on this? I want to explain something there more because that was now 3 weeks. That was like all of OOP, I guess, except state pattern. Very quickly, yeah.
So if the class modifier had a state, how would classes extending it handle that?
Good question. So if modifier had state, so if I had def init and I said self dot state var equals 3, I should get errors over here. So what we need to do is call the super constructor explicitly, because now that I have a constructor, this is something Scala didn't really make us worry about. We did. When we said extends and then we called the constructor right there, we have to do the same thing in Python. Our first line of all these, and literally the first line, if it's not the first line, it yells at me. Oh, come on, IntelliJ, you're letting me down. I wanted you to be abusive. And it didn't yell at me that time. So this call to the super constructor has to be made since the constructor exists of the class that we're overriding. We didn't need that before because modifier didn't have a constructor. Now that it has a constructor, it needs to be called, and it needs to be called explicitly. So if it had params, we would add those parameters here as well. Like if this took some number, we're going to have to give it, some value here. So we're not overriding the constructor. All the constructors through the whole inheritance chain have to be called. And now if I say from store model, oh, no, I don't have to do that. Sale. Oh, no, I do it. You have to take my word for it on that one. If I create a new sale, I'll have a variable named stateVar, which is going to have the value 8. Because I set that state variable, I called that super constructor, gave it a value, and it got that value, and created that state variable. Right. We're at 3:50, so I'll see y'all. I might not see you Wednesday. I think I'll at least show up for the beginning of the TA lecture if I don't stay for the whole thing. Have a great day. I may or may not see you Wednesday.